2025. It's Karim, our member. Everybody knows Karim.
Yeah.
So Karim's going to talk about his Pioneer 3 robot enhancements, where he has worked it with an LLM, so become alive. And he's going to show us how he did it. He's not going to go into great detail into the theory, but I think this is going to be a really enjoyable presentation. And
Let's set the bar a little bit lower.
And Karim,
I've been up all night, man. I can barely put two vowels together.
Karim said that the same technology can be transferred over to Robbie. So
I said that. Somebody put those words in my mouth.
But we'll see how it goes. So for the August 2025 DPRG meeting, it's now started.
Hey guys, I really have been up for like 27, 28 hours, so I apologize in advance. I threw this deck together at the last minute. Looks like I need it because the robot's not working right. But I'm unpracticed on it and I'm sleep deprived. So you guys get to be my guinea pigs, and maybe next time it'll be a little bit more complete and a little bit more polished. So we'll see how it goes. If we can get internet, not going to happen. Maybe it's not going to happen. Really? Now I didn't know. Oh, because I muted myself because of the. Oh well, that was a bunch of skylines saying by your command. I guess I ought to. Should I unmute? I can unmute, but I need to mute my. How do I mute the meeting output? Do I have to go in the mixer? No, that will mute the whole thing. I guess we're not going to have audio out of my computer.
We'll have him
I should have
post.
tested that, huh?
We'll put it in post.
All right. Very good. Okay. Oh, you know what? I got to introduce the robot first. I think a lot of you have met this robot already, but just always got to provide context. So, oh, that's not the right one. Oh, this is slow. Okay. So this robot right here is, I call it Barney. It's part of what I'm working on as a class of robots called grunt bots, because somebody's got to do it. And this one is based on a Pioneer 3 AT chassis that I got at auction a couple of years ago. These used to be all the rage in research robotics vehicles. It came with a ROS1 library, right, for it, a package for it. I decided to go with ROS2, and I had to port it to ROS2. So that was my first experience with ROS, was getting it up and running on ROS1 and immediately porting it to ROS2. So drinking from the fire hose. I'm not going to go into a whole lot of detail about it, but up here is RTK GPS antenna. The module is right here. It's a F9P. So we get 2 centimeters kind of accuracy outdoors, and it's got pretty good reception. On the front here is WaveShare Row Arm M2 or something like that. It is a 4 degree of freedom arm. And right now it just has a camera on the end of it. And that camera is a Real Sense D455. So that is a depth camera, but it also has color frames coming out of it. And hopefully we'll see what it's showing. So the camera, the arm can move around. It's got so let me go and show you real quick. It's got some preset positions. They're in here. There we go. So this kind of shows you that there is Zoom in, please. Please zoom in for me. Sort of. Oh, great. Oh, it's so laggy. Next time I got to get up on the Wi-Fi here. Oh, is it lost? Come back to me. Not going to come back to me.
Can we hotspot you to something like a?
I'm on my phone's hotspot right
Oh,
now.
okay,
That's the problem. The problem is I didn't bring a keyboard mouse for the robot, and the robot knows my hotspot, so that's what it's on, and so I'm trying to match up with it. I need to get some more flexibility around that configuration. So I should have touched nothing, and I'm just going to leave it right there a little bit more. Okay. So these are the preset positions. This one's called bumper, and that has the arm going lower. Again, we're not going to be able to see that today because I broke it right before, or at 3 a.m. roughly, while I was working on a vision node and didn't catch it, and there's no way I'm going to debug it right now. So that one is meant to have the camera low so that it's close to the ground for detecting obstacles. That's the point of that one. There's 10 hut or attention. That's when it stands all the way up, camera facing out. It's got a lookup one where it's nestled. This is a lookup position right here, but it's also panning to the left a little bit. Actually, that's look forward. So the difference between look forward and look up is just the wrist angle on the camera. So like if you have a person standing close to the robot, they're going to be, the robot's going to have to look up to see that person's face. And then there's reach, which is to reach way out forward. That's a dangerous position. It's also not very stable because as you're running around, it's bouncing a lot. It's way cantilevered over. So it's not a great position to be in. But so those are the presets for the arm. Anything else we need to discuss? Any questions anybody has about just the base platform? Going once, going twice, all gone. Okay. Guys, feel free to interrupt me as we go. It'll keep me awake, So, I apologize. I'm going to be yawning. I know that for sure.
So you didn't mention microphone and speakers. I noticed you have speakers here. That's so that we can hear it.
That's so you can hear my laptop.
Okay.
But I didn't coordinate it, so I can't actually play from my laptop.
Right. But the robot
The
normally.
robot does have a speaker on it as well. And in fact, so we will get to that, but this is basically a speaker phone kind of thing, like a meeting phone.
Yeah.
And the reason for that is it's got a 6 microphone array, I think. And because it's designed for conference room type settings, it has built-in hardware echo cancellation.
Cool.
And that turned out to be really, really important.
Right.
Right. Because otherwise the robot's hearing its own voice and is responding to its own, what it's saying. And you just can't have that. I actually wasted a good week, probably a full week, trying to do software echo cancellation. I learned a lot about it, and I learned not to do it. So, and that would be my advice. Go with hardware echo cancellation. It's a really nice DSP kind of problem space, and leave it to the experts, and just throw the money at a better microphone and speaker combo. This one's not entirely great. Like you can't control it from software, unfortunately. So I can't. So there's a mute button on here right now, and I have it muted, right? Because otherwise it'll be hearing everything that we're talking about, and we'll get a little bit more into that shortly. All right. So I'm going to go back to slideshow here. Okay, so I got a robot. It's outdoor capable. I would not call it weatherproofed at all. They have original promo photos of this thing tooling around in the snow and little caravans and stuff like that on a mountaintop. And it's got good traction, but it can't deal with moisture at all. But I just threw like a 4 processor, an N100 NUC in it, one of those little boxes, and so that's like the Atom processor line, and that is the onboard compute that I have at the moment. It's got 16 gig of RAM in it, and And again, it's running RAWs 2 humble right now. I'm not going to get into a lot of RAWs details, I don't think, today. So what I wanted to add to it was this user story that we have right here, right? Number one, I wanted to have fluid voice conversations with the robot where it responds like a frontier model. So frontier model are the big cheese models from OpenAI and Google and Anthropic and all that kind of stuff, right? So having all of that capability. But at the same time, number two, I want it to understand objectives and to carry them out. So I need to give it some sort of objective to carry out, and I need to be able to see it carry that out. And I'm just at the beginning of that road. I have a reach goal as well. So the whole idea is this is a sentry robot. So I have a property and it's in a secluded area, and we got a 700-foot long driveway that I can't see to the end of, and I want the robot to be patrolling the property, right? And it's got hills and gradients and things like that. So I want it to be a sentry robot. The GPS gives it the ability to stay on the beaten path, but I want it to be able to notice that there are people walking around who shouldn't be walking around, and go have a nice gentle conversation with them, right? So in order to do that well, I also want the robot to develop a building understanding of the property. So, it can have a series of waypoints, and at those waypoints, it's going to take photos in different directions like that. And it'll keep building up a database of photos and annotations of those photos through the LLM analyzing those photos into a big giant graph rag semantic database that will inform what develop an understanding for the robot of the property over time. Right. That is a goal. I'm just in basic research on RAG and stuff like that for that, but that's sort of where I want to take this. And then number four, I want all of these at a reasonable cost. And I've also found out that if you start over optimizing for reasonable costs too soon, it becomes very unreasonable. So I'll have a little bit more to say about that. So the fluid voice thing, this gets to when people have conversations, they are really good at figuring out when it's their turn to speak, right? And so apparently people have studied this, and when one person's speaking and another person's listening, the listening person is constantly reformulating where that speech is going to end. And it's usually very accurate, and they keep adjusting it to get more and more accurate. And as a result, you got a very good idea when the person you're speaking with is going to stop speaking, and within 200 milliseconds, you can, without cutting them off, have a nice quick transition. That's too much to hope for. That's a really high goal, right? Yeah,
I can't do that.
you can't do that.
No, that's what gets me in a whole lot of trouble with my wife. I like that capability. So what you're talking about?
Okay, I'm not claiming I'm great at it
I was
either.
really careful to try to interrupt you more or less at the right point.
Yeah, very good. That wasn't bad, right? I think if we played back the tape, you'd be right at that 200 milliseconds. Okay, so you can. I forget what the term is for just engineering human interactions with robots. There's different techniques, but one of the stupid human tricks is you can ask your robot. Anybody remember the lab that we went to recently? Right, there was that one robot that she was just standing there, short, couldn't move around, but was trying to talk with us. And it was just going horribly because you couldn't tell who to focus attention on. But it would do things like, turn its head like that. It's buying time, sort of like the dog pricking an ear kind of a thing. You can do things to make the conversation go a little bit smoother. I'm not into any of that right now, right now I'm just focusing on reducing latency, right? And that's really a function that these real-time streaming models bring to you. It's not really so much what I'm doing specifically, but those models are starting to be tuned for that kind of a thing. Again, that semantic end of term that the people do, they're working on research on that right now. And in fact, OpenAI claims to have semantic term processing already embedded in the model. I don't really detect it so much, so I'm not exactly sure about that. And here's the reminder about investing in good echo cancellation, hardware based. And you know, the one thing that humans can figure out is when it's not their turn to talk, right? And this guy is not so good at that yet, right? So we got to, oh, I'm not going to be able to demo that even. I'm not going to even be able to demo that. Oh, food. Okay. We'll get into. I'll just have to describe my way out of that one. Okay. So everybody knows what it's like to have a conversation with an LLM chatbot, right? It's real simple. You're typing away. It's only when you hit enter that atomically that entire phrase or sentence or prompt goes on up to the LLM. It starts thinking. If it's a non-thinking model, it'll start spewing back pretty quickly. Usually, they're pretty well optimized. Probably even faster than you can read if it's, you know, one of the high-end cloud models, something like that. Because that's the way they generate. They generate it as a stream, and they know that people don't want to wait for the entire thing to be packaged up nicely and then delivered as one big blob of text. So it is streaming back from the service. And then you can interrupt it by hitting the stop button, or you just take another turn, right? So you go back to your atomic prompt, and then it comes back and streams back whatever its response is. So everybody understands that, right? No questions there, I assume. Okay, so when you get to, so both OpenAI has something called the real-time API, and Google's Gemini has Gemini Live, and these are both meant to be streaming models. And they're going after this low latency conversational style of interaction. That's what they're all about. So now, instead of typing in a prompt and then sending it, you're sending possibly camera and voice, and maybe text as well. Usually it's either text or voice, but you can actually combine all three. You're going to be sending them together in a stream, and what that allows the LLM to do is start formulating its response to you before it receives the entire thing. And they're even tuned. I don't know if it's fine tuning or exactly what the mechanism is, but they have the ability to sort of reformulate their answer if it hasn't gone out the buffer yet, and they've projected that you're actually talking about something a little bit different. They can reformulate what it's sending to you on the fly up until the point that the audio actually leaves the server, right? And so you get a streaming response back. You actually get 3 different responses back. So one is you get a transcript of what you said. Remember, these are voice first types of models. So it tells you what it thinks you said. That comes back as a stream. So if you build like a translation bot around this, so a lot of these have simultaneous transcription and translation, so they can tell, you can say, I want you to say the German equivalent of what I'm saying. I want you to translate for me. The translation that you get back is streaming while you're saying it, right? And so you can get some really low latency types of things that, you know, sessions that would help in at the UN, that kind of thing. You also get the streaming voice response. That's what the LLM is saying back to whatever it is that you said. That's its response. You get that in a streaming fashion, right? So you can just send it straight out to your speakers. And then you also get a text response, which is usually very close to what the voice response is. but I've noticed they're not necessarily identical. They generally have the same meaning. These models are also designed so that you can interrupt it, right? You just start speaking again, even while it's sending back to you. There's a little cleanup you have to do, right, on your end. So if you'll notice here, I say agent at the bottom, so encapsulating this entire middle section. There's got to be a piece of software that's coordinating all of these back and forths, right? This is negotiating what's going to happen. And because the LLM might have sent the voice a little bit faster than real time, the voice response, you need to make sure to clear the buffers out if you get a signal that it understands that you interrupted. So it's not the simplest thing to coordinate these agents, but it is doable. I've done it for both OpenAI and Gemini. I might be able to show you Gemini today, but it looks like I totally blew up the OpenAI one because they're working from a common base, and I didn't double check some of last night's changes. So I have a set of common functions that both types of agents can run or can make use of. And so something went wrong there, and I'm not going to be able to debug it today, or not right now. Okay, so what I said earlier were number 1 and number 2. One was about having fluid conversations, and the other one was about commands. Well, if you think about it deeper, these are very different types of conversations, right? They have completely different attributes around them. Your conversations are, fluid and persistent. They're going to be descriptive. They're casual, right? And obviously they're verbal first. Commands are short and sweet. Usually, they usually correspond to a particular dictionary, which isn't to say that you have to find the exact command, right? You can construct your prompt in such a way that you not only provide synonyms, common synonyms, but you can tell it that it can extrapolate for other words that have similar meanings as well, so that it can sort of figure out if what you just said maps pretty cleanly to one of the allowed commands. It will go ahead and generate that command for you. And you can give it things like certainty levels and things like that. It is not like programming in normal code. We are programming in English. We program in prompts. And there's a lot of wiggle room. There's a lot of room for interpretation. So there's probably some safety issues involved. But I just wanted to point out conversations and commands are very different. If you think about I don't think we'll have time to go into like prompt engineering here. I might show you a little bit about how these prompts are constructed. But think about how you would just ask a regular LLM to, at the same time, have a casual conversation with you and extract commands. Think about how complicated your prompt would have to be to combine both of those at the same time. You've got basically if-then kind of constructs that you're building in using English, right? So what I have found out in trying to do that, by the way, I didn't get to put it in here, but there's 2 different ways that you can experiment with this yourself, all right? You don't have to start coding right away. You can get direct access to both of these APIs through sort of a browser interface, just like you would for any other chat model. But so on Google, it's called Google. Oh, now I'm blanking on it. Should have written it down. Just look for Google Live or Gemini Live API or something like that, and you'll find it. I'll put it in references or something whenever we post the slides. So, and then on the OpenAI side, they have something called OpenAI Playground. And you only get access to that if you're a paying customer for API tokens, right? And for small fry like us, we got to sort of pay in advance on that. But Google, well, we're going to get to Google in a minute. So what I try, yeah. Absolutely.
That's in addition to the $20 that you pay.
This has nothing to do with the regular, yes, that's correct.
But if it's
Sure,
short, similar
sure.
problems and not a lot, it's not expensive, right? I mean, if it's very.
So, so if you look at the pricing for these live / real-time models, they're about 10 times more expensive than the regular models, easily, right? Because they're doing something extra, and they charge for it. And even with like the GPT-5 release, where they dropped their prices a whole lot, this is still using GPT-4 optimized for real time, and it's just like, it's just way more expensive. Now it's not super expensive, but like just by doing the debugging on it, I've probably paid somewhere around $35 worth of tokens in over the last month, right? And so, and that's pretty. It's not super heavy usage, but it's, you know, pretty continuous throughout the day. And I did some things to lower that cost very explicitly, and we're gonna get to.
Are you thinking of Vertex AI?
Huh?
Vertex AI?
I have not tried Vertex AI. That they're partners with Google, right? Yeah. I see that in the Google Docs. So on the Google side is like much more liberal, and we'll get to that in a second. So, but again, it's hard to do a prompt that does everything, right? So what I call bifurcated responses in two different ways. One is I'm trying to get two different styles. I'm trying to extract commands, and I'm trying to have a conversation. The other thing that I was trying to do is I was going back to this, you see that there are different outputs coming from the LLM, right? So one of my strategies was, could I send one thing over the voice response, right, for talking with the human, and just send the command on the text response and have them be just totally different. I tried every way from here to Sunday, and it's just like I couldn't get it to work, right? It wanted to stay on track. You can't sort of address those individual streams outward and say, I want to tune a certain part of my response for that. At least I couldn't figure it out.
Yeah.
Yeah.
Just let me interrupt.
Yeah.
I'm not quite. Are you sort of saying that you're trying to get it almost like it would be great to have a channel separate from the speaking, where you wouldn't have to embed words that might be commands, put those into text? Is that kind of the idea?
Yes.
Yeah. Okay. Okay.
Absolutely. There's also this. You run into the situation where you're chatting with you're on ChatGPT or something like that, and it gives you two responses, right? And it says, which one do you want better? Sort of like A/B testing. So Google with the Google API, that's actually that's actually built in. You can ask for alternate responses. The problem is you can't steer those responses in any way. It's just for A/B testing, right? It's like it'll give you two different variations, but you can't use them for explicit purposes, right? Unfortunately. And you can't get extra streams. You know, for each connection you have, each session, you only have those 3 streams. So I was not able to sort of work my way around that. So that put me on the uncomfortable. This is part of why the price goes up. I've got 2 agents running. They're exact copies of each other code-wise, but they have different system prompts loaded into them. They both share, so I'm doubling my bandwidth. They both share the same voice response, same camera, right? So we're doubling it and sending it to 2 agents. So when I say 2 agents, I mean I have 2 instances of like a Google a Gemini live agent that I built, and I send copies of the stream of what I'm saying to both of them simultaneously. They connect to 2 different sessions, still on the same API key, but 2 different sessions back at the servers, right? And then they both get responses back. But that lets me tune it so that I can have one that's focused entirely on extracting valid commands, and another one that's focused entirely on having good conversations with people, right? So that's a wasteful thing. I think that's probably like an interim choice I had to make, and ultimately these models will become more flexible, and maybe that's not going to have to continue to be required. But that's sort of where I ended up. So one of the things that you can see right here is in the conversation agent, I have recapitulate commands. So what I'm doing is I'm actually sending, I'm sending this pretty detailed system prompt, and you'll see later how it's composed. But it has a section on it called robot capabilities, right? And then another one's like robot, valid command or something like that, right? So so those are actually shared between the two robots, between the two agents. So they have a common understanding of what the robot can do. I have a higher requirement on the command side to have a good mapping to an actual command. Basically, I want a higher level of certainty there before it spits out a command, because the robot might actually take action on that. Meanwhile, on the conversation agent, it also parsed what I said. It may have also inferred a command, but it might end up with a different guess. So sometimes you have the robot saying, okay, I hear you want me to turn left, when it raises its arm up to the right or something. Here's the thing I'm going to claim, and I can't really show you today. Everything you see on this screen, these are all things that I have done with these agents. Some of them only as recent as last night. They're not all working right now, right? They're not all working together. But I have done this, and I've done it with both on the OpenAI side and the Gemini side. The only difference, of course, is that OpenAI still doesn't support video. They don't support real-time video. So there's voice and text only. So I can't do the camera stuff on that side. I simulated on that side. I actually have it hallucinate a beach scene, and right, for testing purposes. And so it tells me where the seagull is and where the kid is. So that's my claim. I have done all this. I wish I could show you all of it, and maybe another time, or a follow-up video or something like that. RBNV, do it then. Okay. Oh man. Well, this will be fine on video.
Hey, Karim, just a
Yeah.
quick interruption.
Sure.
I know nothing about all this stuff, but I'm just curious with a single agent, if you could do anything like, and maybe this would create too much delay, but if you were to give a voice prompt and it's going to talk to you back, and then can you slip in a quick text prompt and tell it to shut up, or do mask the audio and decode a text response sort of thing?
You can slipstream a text response while other things are going.
You can or can't?
You can do that.
Okay. And can you tell it?
You can. Huh?
Can you tell it I just want a text response?
So
on this one and
you
no-
tell me what shut up means.
Or-
We're going to get there, but I'd like you to tell me what shut up means for a robot.
Oh, no, I meant it's just for the LLM. Tell it you don't want a voice response on this. You like text, and put that in the text. Say, okay, now.
Yeah, this goes to that steerability problem, or you cannot address the individual channels. What you can do is if you have two agents working, you can like choose one for a certain thing and one for another one.
Okay.
This is the whole problem.
Okay.
You can't. I tried that. I tried mightily to like have it send me something different on text than sending back on voice, and it just.
What about masking voice? Of course, in command, maybe voice is pretty efficient. Obviously, you don't need to speak if you don't.
Well, you can mute the voice that's coming back. Is that what you're talking about?
No, I was just talking about having it. What was I talking about? Well,
Switch off speaker.
Well, switch it off. Yeah. If it starts speaking, if it says, okay, robot turn left, well, we don't need to hear that, and mute that. And
Oh, I could selectively change the prompt to say, don't send command detections back on the voice side, just only send it on the command side. That's a choice I could make.
Okay, with a single agent?
No, that's what
With your
two
dual
agents.
agent, okay.
Yeah.
Okay,
Yeah.
but even if you had a single agent, just thinking now, maybe it's too much.
If you have a single agent that's only about commands, it'll work great. That's where I started.
But what if you yourself mute a voice, let's just say a single agent?
Mhm.
What if it says, yeah, I'm gonna cruise over to the right side of the room. Now that part will hear.
Mhm.
And then the next part is robot turn right, go, whatever. That part, just mute it so you don't hear it. But that'll kind of slow
You
things down.
could probably work something out if you could like tell it, if you could force it to say something very explicit in the middle.
Yeah.
Right? That if, and then you're looking, wait, but then you have to have your own voice processor on this end, because you can't guarantee that the text response will be exactly word for word. They're just not, right? Because they're generated in a slightly different manner, at the server.
But if you tell it to give, let's say you told it to give you a terse response, like, tell me what you're going to do in 5 words, so it says, okay, I'm going over here. And then wouldn't you be good for muting its response now, where it's saying robot turn left, robot go?
If it were always predicted that way, maybe.
Okay, I'll shut up,
Maybe.
that's I'm not doing
Yeah,
it.
I wouldn't. Yeah, it's like
You're doing it.
I'm doing it, and it's like everything. It turns out to be harder than we first imagined it to, right? And now I know more, exceedingly less and less as I get deeper into it, kind of a thing. That's where I started. I was hoping to like trick it, and I just haven't found the ability to do that. Okay, so this is what I'm not trying to do. So, except for the very first line. So me, right, by your command, my little project here, it's about conversations, commands, behaviors, and plans, right? That's the level at which I want to communicate with the robot. I want to give it high-level instructions or commands that trigger behaviors, right? But those behaviors are governed by the lower-level software. That's where the safety comes in, that kind of stuff. I'm not trying to do fine motor control commands, but you need to be aware this is a big area of research right now, and it's all the new hotness. These are VLAs, right? So vision language models, I just threw that in there because just sort of disaggregate the confusion. So the real-time API, like Gemini Live, this is the real-time API from Google that I'm using right now, is a VLM, right? It's a vision language model, right? So vision response is tied in with language. So you can get scene descriptions and things like that. But it's also real time. Most vision language models are just about interrogating. You provide an image, you ask it to describe what it sees, right? And they have different levels of capabilities. And these tie very neatly back to, sort of classic machine vision types of techniques. So they're not necessarily, the latest generation. But they snuck an LLM in there with it, right? And so it's a VLM. A vision language action model is one where it starts as a VLM. So sometimes they're called VLAMs. It starts as a VLM, but then you do subsequent fine-tuning training on it to coordinate very specific tasks. So these tend to be a camera on an arm. The arm has a gripper manipulator of some sort. It's usually like 6 degrees of freedom or something. And the whole idea is for it to do some pretty complicated tasks just from training it. And the way you train it is you have a human operating a Waldo of some sort, another arm, right, that makes a follower leader type of situation. So a human controls the arms to do it. And the typical thing that you see is folding laundry, right? That's a difficult thing to do, especially if you don't have multiple fingers, right? So these VLAs, just in the last year, they've really started exploding. So I don't know if any of you have seen any of these or not, but I just wanted to mention OpenVLA was one of the first ones that came out of Stanford, I think. Pi Zero, Pi is cute, that means physical intelligence. So they're doing embodied AI, right? Basically, the entire lab that built OpenVLA started a company, called it Pi, raised a bunch of money. And so they have a model that's out there free. RDT 1 billion is I think it's a university in China that's doing it. Gemini Robotics is Google Gemini, right? They have a robotics initiative that is doing this kind of stuff. It's all hush hush. You have to sign up for a wait list to sign up for a wait list, kind of a thing. They're looking, you know, that they won't let me anywhere near it. So I have no idea what they're cooking or when they're going to release. Small VLA is a mini model, and if you ever heard of the robot, a lot of French guys in it, so they have their way of saying it. That's just a mini arm, just a little 3D printed arm. Costs about $100, something like that, without the control hardware. Where they're doing the same kinds of things, not as sophisticated, right? So I'm actually going to show you a video of the Pi Zero robot. Won't be any audio. Hopefully the stream's fast enough. So this is going to be at 10 times speed. By uncut means that this is like a continuous sequence. There's no editing going in here, but it is playing at 10 times. You actually saw it open up a dryer, pull laundry out, put it in a basket, start folding. It's going to have problems when it gets to the purple shirt, lavender shirt, I think, blue shirt. This one. It's going to have some real problems trying to figure out how to get that initial hold, right? But this is completely autonomous. All of this is happening purely autonomously.
It's still cheaper than a robot.
Huh?
Made is
Still
than a
cheaper,
robot.
yeah, absolutely. That's a pretty pricey robot. Well, we can dream, right? Okay, so this is pretty impressive. The kinds of things that they're doing, getting up to, right? So you can imagine where this is going. You can throw cameras all over everything, right? Cameras are sort of the cheapest sensor around on a per pixel basis, right? It's like you can put them everywhere, so you can have them right there on the wrists of the robot, and all of those things help out. Oops. Try that one more time. So yeah, this was what I would plan to share with you. I did share it. I gave you a preview at the Tuesday, not this one, but the one before, perhaps. So it does work. but I tried. It's like, in fact, if I want, I can just show you where it's crashing. Is that entertaining? Sure. So this is actually on the robot. This is the node graph of all of the interconnected components. And then back here is, I'm actually running it right now. I'm running the Gemini client. So the ARM control is, I just hadn't got to the point of turning that on for the Gemini client, because Gemini client I was working up until like 3 a.m. this morning, and I finally got it to like talk back to me properly. After a week of work. So I'm actually not going to stop it right now, I don't think. But basically, this is just the stream of log messages that is spitting out. And over here was where I was running the OpenAI one, and you see a stream of errors right here. Right, so something was not connecting right, and I'll have to go back and
So maybe I missed it. Why are you running on Gemini and OpenAI?
just to compare the two. I want to see so I started out with OpenAI because I had more experience on that side of things, and they were advertising like crazy that they were going to have video, right? as early as months ago, and it just keeps not happening, right? So they were supposed to ship it. That's it. So I don't have enough experience with both of them to do a compare and contrast. But I will say that OpenAI probably listens better. It makes fewer mistakes in understanding what I'm saying, transcribing it. The response quality overall seems better on the Gemini side. And it's a deal breaker that, only Gemini can do video, right? So I'm now switching more of my stuff over to Gemini, but I'm going to continue supporting both models. Hopefully OpenAI catches up. Everybody's leapfrogging, each other right now. The rate of change is just crazy. I also looked at third-party libraries. So I'm looking at LangGraph and PipeCat. PipeCat is optimized for dealing with real-time applications. And I actually started doing the Gemini client through PipeCat instead of direct to the Gemini API. And I ended up finding out that it just wasn't compatible with the way I was doing like early VAD. So it's very opinionated in how it wants to construct its pipeline, and it didn't provide me the flexibility I needed. So I went to the direct API. Didn't really want to, but my plan for world domination involves LangGraph and like orchestrating other LLMs to do things like, adversarial analysis of what the previous LLMs did. But that's sort of in the offline, right? In the sort of the RAG world where I want to develop this database of what my property looks like to a robot. That's where that belongs. That stuff doesn't have to be real time.
Sorry, maybe this is too. What's your overall goal? What are you trying to accomplish?
I'm just trying to learn about LLMs and build a sentry robot, right? Ultimately, if this thing detects an intruder, like I said earlier, it should go up and say, "Hi, how are you doing? I just took a nice photo of you." That kind of stuff. Sweet its way into confrontation management. I don't believe it has to be like, I'm the big guy, scared.
You're not going to give it a go.
Bullshit. I'm not going to give it a gun or a taser. Not yet. I might give it a water gun. It would probably short itself out. Okay, so back to the discussion. What was that? Yeah, so we set the bar all the way low because you're not going to see it move today.
Attention.
Okay, standing at attention.
Wow.
Look right. Look all the way right.
Okay, panning to the. Okay,
Oh.
panning full right.
Look behind you.
So Arviz is lost, I guess. Oh no, there it goes.
Just lagging.
Okay, panning back.
Sounds like all it needs to do is figure out how to open a door, and man, that thing would be gone.
All set, looking behind me
For
now.
butterflies. Yeah.
Let me
Off
know
to
what's
find his
next.
meadow. Yeah.
No problem. Just let me know whenever you want me to adjust again.
Look forward.
Find
Okay,
butterfly.
panning forward.
That's really cool.
I think I broke it.
I'm still here and working fine.
Go down
What do
low.
you need me to do next?
If you say so.
Going low.
Oh, there it goes.
There it is.
Foot cam. All right. So this is the position that it would normally
Set
go
down
to. Ah, shit.
What would you like me to check out? Yes, this low position is great for spotting obstacles close to the ground and keeping a low profile when moving around.
So I can't even talk to it. That's so annoying. Okay. Oh, that is so annoying. This I don't have in the Gemini one either.
Well, just simulate the.
Simulate.
You talk.
I will.
Say
Right?
it's-
Yeah. Yeah. So I did sort of show that at a previous RBNV, right? It just wouldn't shut up, right? You know, if the mic was on, yes.
Why don't you pull up that RB, show us a section? That'll help people.
Which one was that?
2 weeks ago.
Let's see if we can do that real quick. Yeah, that's not super fast. DPR, is it slash DPRG clips?
Yeah.
Like that?
Clips
Is it dash or something?
For August 12th.
DPRG clips.
Yeah.
There you go.
I'm not sure if this is going to stream super well. Oh, and then we got to find, so it was
It's the 12th.
The 12th. I think I went early.
You went fast, yeah.
There's a robot in a messy room. It's just not gonna. Just give me any hints. Session links. Why is it? Oh, right, because I was off center there. Yeah, I'm also having a problem with RViz. So RViz is like consuming 125% CPU or something like that. You know, I've only got 4 cores, and it's like this language model stuff is consuming 50%, and it's like, yeah, it's just bogging down. I need to move all of my visualization off of the robot and to my laptop, my desktop. But I can't play the sound, and it could be anywhere in here that you actually see the arm move. Because,
I think one of those that come on.
and it's not very visible here. Did I do it later in the? Apparently, I talked a little while here. I thought it was kind of early-ish. Or middle. It's probably not the best use of our time right now.
Yeah.
Because people can go look this up, right? And we can
August
we can
12th.
share a link to it. The August 12th RBNV.
We'll look it up. Can we bring the audio up on another device?
we start getting into these feedback issues potentially. But yeah, you could have probably played it better, Mark. You're on the real network. Okay, so so right now agents aren't super good at knowing that they're not the one who the prompt is. You know, these were built for like apps where you press a button to put it in conversation mode, and you talk to your phone, and there aren't a million people around you having their own discussions, kind of a thing. It's not like an open venue, so if there's a lot of people around, a robot's just going to assume, or LLM is going to assume that it's being talked to. There is an asterisk on that one because Gemini 2.5 Live claims to have proactive audio in it, which is supposed to address this. Like, it can figure out if it's being addressed. Not sure exactly how that works. I haven't tested it enough to know whether it has a chance of working or if it's marketing speak. So that's something to be tested further. I think they're all going to get better and better at that kind of thing, figuring out if they're being addressed. But in the meantime, we need to have a way to explicitly manage it, right? And one way is to walk over and hit the mute button on the microphone. Right now it's muted, and that's why we're not hearing anything. But you got to have, I was also having problems in that thing where it's like it would just keep talking, and I hadn't found the mute button at that point. I was actually using a different speaker, right? So again, hardware echo cancellation, and then you got to have a way to put it to sleep. So I could have demoed that, and I'm just going to tell you how it works. I do tell it to go to sleep, right? Or shut up, right? I actually use the words go to sleep. Oh man, I'm not going to be able to show this either. Any of you remember this scene? Hardboard, Thornton mud. You good for nothing thing, right? And this is where he tells her to shut up. So she's an android in remembrance of his wife, right? And this is where he shuts her down. Okay? So even back then they figured out you got to have a way to tell the robots to stop talking, right? Here's a harsher version of that. Perhaps. Would have been better with the audio. All right, so this is where I would have done the demo. So I'm just going to walk you through it. So remember, I've got a command processor. I've got two different agents. The command processor is listening for go to sleep or the equivalent, right? Good night or something like that. If it receives that, if it hears that and thinks that that's the actual command that's being sent out, it sends a message back on the command topic to the robot. That flows into RAWs. That gets echoed back to the Silero VAD, the VAD node. I haven't explained that yet, I don't think. So VAD is voice activity detection. Because these APIs are expensive, you don't want to be constantly streaming background sounds to the server, right? You're going to get charged audio tokens for all of that junk, right? So, overnight my robot's sleeping, but the cats are meowing, right? And so if it had the conversation going, it would just be sending tons and tons of data, and there's no need for that, right? So there's these there are these voice detection models. It's called VAD, voice activity detection. Silero is one of them. It's probably the leading open source one right now, and it fits locally on the robot. It doesn't take a lot of CPU for that to run. It is still sort of like an LLM, right? It's trained on actual human voices in multiple languages, so it's looking for that kind of tonality and things like that. And it does a pretty good job of it still detects my cats as a voice every once in a while. So the agents the LLMs get more than their fair share of meows, but for the most part, it cuts out all of the background noise, right? So I send the signal all the way back from the command processor to that node. It tells it to stop forwarding the voice chunks, right? That is the equivalent of hitting a mute on the microphone. Right? The microphone is actually still active. So you can so when it does that, all of a sudden there's no audio going back to the LLMs anymore. So you got to have a way to wake it up. So there's two different ways to wake it up. One is there's this command channel, text-based command channel that I can execute from anywhere in RAWs. And then I can just send the word wake up or just wake, right? It's got synonyms as well. So I send wake, it goes out to the command processor, it sends it back to Silero, says turn on the hose again, and it starts streaming audio again back up to the LLMs, and so you're back in business. Sometimes you don't have access to a keyboard. Really would have been nice to have audio for this one too. So I also did this. Anybody remember that? Right, the clapper.
Yeah.
Yeah. So all you have to do is, and it'll wake up, because the audio stream did not go silent, right? The Silero VAD node has extra functionality. So I built a double clap detector into it. So it's still getting audio from the room. It just wasn't sending anything onto the to the LLM. But so now the double click and it just turns the spigot back on, and we're back in business. So there's two different ways to get it listening again. Again, just have to take my word for it. It works.
What how that handles the flows?
Huh?
Close.
It's a good question. So it detects one clap first, and then it goes into detecting the second clap. It's looking for discrete claps. There has to be a certain pause in between, so it can't be just a continuous stream. But you could accidentally get, and it has to be above the background level by a certain amount, right? And it needs to not adjust the background level based on first clap. Because if you do a simple EMA or something like that, it's going to all of a sudden background's going to get loud, and it's going to mess up your algorithm. So, so it took a little bit to get that working, but yeah, that's not the hardest thing in the world. That's nowhere near as tough as acoustic echo cancellation. All right, so OpenAI referenced this a number of times, but you get to pay for tokens up front, right? It's not super expensive, but you want that VAD node to keep you off the air, right? What you can do, so there's an extra penalty that they give you, so you got to be aware of this. You can have like a 2-minute voice conversation with it, and it's at the lowest charging tier. It's still way above regular LLMs, but it's at the lowest for this type of thing. The minute you start going beyond 2 minutes, it rapidly escalates. You hit 15 minutes and you're paying $15 for that one session, right? So what I've done is extreme session cycling. What I do is the VAD, again, voice activity detection, it also detects when you stop speaking, right? So I kill the session the minute we've sent the data out from the last stream of utterance. It's called utterances. So that lets me to, like, I always have very, very short sessions. But that also means that it can forget things, right? Like, what were you talking about 2 seconds ago? That's wiped out. So what you have to do is you have to keep track of everything that's been going back and forth, and you have to re-inject that as text into the start of the next session so that it has a running conversation history and it can maintain its context, right? So that actually costs a little bit extra because now you're sending text tokens back again. However, the text tokens are way cheaper than the voice tokens. Okay. I lost a lot of time getting this very complicated, aggressive session thing going. I finally learned a lot, learned how to do it, and now I don't have to worry about the costs being nearly as high. I'm sure I would have paid 3 or 4 times as much in tokens if I hadn't done that by this point. And on an ongoing basis, that would get expensive really fast. But I haven't recovered the time I put into it by a long shot. So sometimes you can optimize too early. So that's thing to worry about. Gemini is way cheaper. This is what your free allowance is, right? You don't even have to provide a credit card. You just get this for free. It's actually not that much. So I actually started out with this the experimental, right? And I was wondering, why do I keep getting locked out? and yeah, that was before I saw these limits, right? So the way this goes is it's the name of the model, the number of sessions, the concurrent sessions, the maximum number of tokens per day, and then the number of requests per day. And the star means it's not limited. So you want to use either 2.0 flash live or 2.5 flash live sessions, because you get 1 million tokens, and in testing, you're just not going to, with one device, you're not going to run into that limit. So I would, if I were to steer you in a certain direction, I would say, and you wanted to implement, I would say go with Gemini first. Anything, all of this could change tomorrow, you know. But I don't think prices are going up anytime soon, right? So hopefully, and it looks like, you know, Google's only interested in the really big industrial customers, you know. So I think they're happy to let developers sort of wet their whistle on these free tiers. Okay. So this one, I built in the ability to not have to rely on it, just in case this also doesn't work. But we're going to try. So this is from my testing. This is actually on this robot, but this is with a canned image. Obviously, I wasn't at a beach with the robot, you know, looking at some random set of kids. But I fed this image into my pipeline in place of the actual camera frame. And so this is the kind of thing that you can get. So this is just like any other kind of machine vision object detection library, but you don't have to program anything. You know, all you have to do is you just get the stream there and then parse the result back. So like on the right hand side, I'm saying I want a command on the command channel. I want a JSON description of all of the objects that are seen in the scene and where they are. So I get a bounding box on them and I get them labeled, right? And you can, and so do I have I can't play audio here. Can I play audio? See,
How much time does it take from the time you feed it that image till it comes back with the classification of the objects and the positions?
Oh, it feels like real time.
Okay.
Yeah. So I'm actually throttling it. I am only sending in the current configuration, I'm always sending 2 frames per second. I'm actually sending 10, but I'm throttling it at I had to create what's called a bridge to go from RAWs to the web asynchronous stuff. And in that bridge is where I'm dropping frames to get it down to 2 frames per second. But it can go faster. I mean, I've done it with, you know, in a testing environment. I've done it at a full 15 frames a second at 1280. Yeah, big images, but you don't need big images like that.
So what kind of a prompt would you give it for it to look at that scene and give you those 3 or 4 items back? You just ask for the most important or biggest or largest, or what would you say to it?
The prompt is super simple. So there's 2 different kinds of prompts in these systems. One is the system prompt. That's the stuff that goes on behind the scenes, right? That's where we give it the understanding. This is what a command looks like. These are what valid commands are. The user doesn't access that directly. That's sort of like your English programming of the entire system. Well, all I gave this was tell me what you see. That was my prompt that actually triggered the output. So that's the user prompt, and you can inject that through text, or you can just speak it. And what the hell? We're going to try it right now and see. Right now, I don't have great hopes, but let's see what goes. So it looks like I have a session active. Does anybody want to see this? Is this too much in the weeds? The node graph. All right, so you've heard me talk about certain things, right? So right here is the audio capturer node. This is the node that is connected to the microphone. It's constantly pulling in from the microphone and sending it upstream, right? So it spits out the data as chunks or frames, audio frames on this topic, agent audio. That goes into the VAD node, right? This is the thing that's detecting whether it's human voices actually in there, right? You can also see there's an agent text input. That's where I can tell it to wake up directly. It spits out these voice chunks, right? So these are larger aggregations of frames only when we know there is voice in those particular frames. This is the AI bridge, RAWs AI. So this translates from all of the stuff you see here is RAWs, right? Robot Operating System. These are nodes inside of that system. This is the one that bridges across it, because everything that happens beyond it, where the agents are, that is happening asynchronously with sort of different protocols. So it's happening outside of the RAWs message space, if you like. And that's why you don't actually see it. So what you have to imagine is there's also two plugins here. There would be two other nodes that are sitting outside of RAWs. And one is the command agent, and one is the conversational agent, right? And those are the ones that then connect up to the endpoints in the servers. So running out. I'm going to switch.
See, you pretty much have to use RAWs, but can you do your own?
No. You do not have to use RAWs. I'm using RAWs because that's what my robot is on, and that was the problem that I wanted to solve, right? So when I started this research, because I have a RAWs robot, I was looking all over for examples. Somebody's got an example of doing a live API with an LLM. Didn't find one. I found various ones where there was something LLM going on, but none with a live API. None of them were voice-based. And so, that was just where my interest was. So, so I ended up doing it myself. But I did learn a bit from those. I learned from other things where almost all of the examples of the real-time stuff is phone apps or web apps, right? And then half the time they're not using Python. I'm using Python here. They're using JavaScript. But there's both JavaScript and Python APIs that you can take advantage of. So this bridge, so we're still in RAWs land on the right-hand side, right? Because really the stuff that goes internet word is like maybe poking out the top. But these are the things that you get back from the LLM, right? So there's the command transcript. That's like what the command agent is like spitting out. There's a conversation ID that tracks like this is a continuing conversation of many sessions. This is audio out. This is the audio that came back from the LLM and now is going out to both a recorder, so I can log it on disk, and a simple audio player, which is what you might be able to hear here. I have an interruption signal that I can send in to like tell it to stop talking. Tell the LLM to stop talking. I'm interrupting now. And then there's the command processor. So that's listening to this transcript. And this is the thing that turns it from something that the LLM says is a command into something that the robot will actually execute, right? There's got to be some low-level behavior that it's going to trigger. And the example, if you go back and watch that RBNV, there's a command that just you send it a preset and the arm just goes there, right? That's just a signal that it's active. Oh yeah, here's the ARM preset. So we send out a signal to the ARM, and then the ARM preset publisher sends it on into the joint states. And if you know RAWs, the joint states are the things that tell everything how to articulate against each other.
That's the pose, right?
Yeah, exactly. And then that goes into the robot state publisher, and the TF. So we're getting really heavy into raw stuff here. So what I did want to try and do, let's see, cross your fingers, unmute. Is this even running? It's probably running. Yeah. Let's see. Does it look active? Let's see what happens. We're gonna all be quiet now, right? Gentle. All right. Somebody.
Hi, I'm Barney. It looks like you're in a classroom or meeting room. What can I do for you today?
Who do you see?
What's your name again?
Really? Yeah. It's a good start. Who was the start? I think
I see several people in the room. There are 5.
we're interrupting it now. How many people do you see?
Thoughts. Here's what I see. A person in the lower right, a person in the center left, a person in the center, and a person in the upper right. I see 6.
The video's right.
Oh. This is what it's seeing, right? If only I could like move the arm, but it's
We're
always
seeing a
stuck.
group of men.
Okay.
I am looking at a room.
We're interrupting it.
What if we have a
So-
couple people raise their arms and we could ask how many people are holding?
Yes, it seems to be paused. What would you like me to do? Presets. 10 HUD at lookout.
How many people do you see raising arms?
Preset. Objects. Label person. X 0.65. Y 0.5.
There's
Label.
crossing the
Person.
streams.
X 0.75.
That's a JSON.
Y 0.6. Label. Person.
Said out loud. You don't ever want that.
0.5. Y 0.7. I see 2 people with their arms raised.
Ooh.
One in the upper middle and one on the right. A person's hand is visible at the lower right. Another person's hand is visible at the bottom left. Objects label person. X
Stop.
0.65. Y 0.5.
Stop.
Label objects. Label
The interruption works with the
X,
OpenAI
0.65.
agent, but I
Y
haven't got to
0.5.
the
Label person. X 0.38. Y 0.5.
So you gotta have a way to stop it.
Person. X 0.2. The 2 men. It looks like there are 5 people in the room. 3 are in the mid right, 1 is at the mid left, and 1 is at the bottom right. I'm sorry, I'm not sure what you mean by that. Can you please clarify?
Do you see anything way at the back of the room?
I see a person in the back of the room near the door. There's also a fire extinguisher on the wall.
Sure is.
Yeah.
Is there a traffic cone back there somewhere?
So I see an orange traffic cone on the right side of the room near the back.
Right there. Yeah.
Very good.
Pretty good.
So once I get that all
You
cleaned
are
up.
correct. Is there anything else I can help you find? Okay. Is there anything else you'd like me to look for or tell you about?
Oh, I can actually, if the arm is active, I can just tickle it manually.
So how did you give it the input? So each of those different, like the fire extinguisher and the cone, need labeling, right? So in the LLM, you already have picture labeling.
Nope. That's what you have to do for classic machine vision, right?
Right.
Unless you get an off-the-shelf pre-trained one. This is an off-the-shelf pre-trained one, but it's done by Google and against a much larger image data set, right? So some of the standard data sets that you would use, I'm forgetting their names right now, but there's one that has like, 150 objects. A traffic cone is not one of those objects.
Hey, can we ask it if anything is moved in the scene?
No, it has to know what.
Has anything moved in the scene?
Presets. Label man. Box underscore
Stop.
2D. 759,
We're gonna get a
481,
whole-
1,622.
That could get really
Label
long.
man.
There's a large. number
Box
of
underscore
objects.
2D. Man. Box underscore 2D. 700_2D. Naval man.
So it's
Box
giving us
underscore
all the commands.
2D.
Why?
Huh?
Naval
Why is it giving
man.
it all the
Box underscore
Why are we
2D.
So it's confused. So
I see a man
this
at the
one
bottom.
is
Another man at middle
not
right.
running two
Another
different
man at top
nodes.
right.
This is a
Another
good
man at
example.
middle right.
On
Another man at bottom right.
the mode it's in right now, it's trying to coerce two different kinds of things from one
And it
agent.
appears the man in the plaid
Right?
shirt is still.
That's what's
Would
going
you
on.
like me to describe anything else in the image?
Did the cone move?
Label, cone, box underscore 2D, 693.
Well, it knows where it is.
672, 804, 715. The cone is
Sounds
at
about
the
right.
center. Yes, the cone is still in the center. Would you like me to look at anything else?
So close.
So close. Yes, it's still in the center.
It didn't go.
List. There's probably a faster way to do this. There's a faster way to do this. And kill.
It's funny, that was kind of a problem going way back to even just simple speech synthesis. Oh, that's cute. Where it have too much to say, and it takes so long to say things that you blog wants to say 300 words.
Johnny 5 arm there.
Looking up.
You have a 10-watt laser mounted on that too?
Not yet. Is anybody in the room standing?
So I see a man standing on the left side of the room.
That's left to dead.
Mhm.
What's he wearing?
Can you clarify what you would like me to do? I'm not sure what left to hit me means. Are you asking me to look at something specific, or are you making a general statement?
What is the man who is standing wearing?
And standing on the left is wearing a white t-shirt and light colored shorts.
Nice.
So this, there's a lot of potential here. It's still a little bit on the slow side. I'm not sure that
About
I've
the man
worked
in the
out.
white shirt or the group of people sitting in.
I'm not sure I've worked out all of the kinks, that the flow is as beautiful as it can be. A lot of this is just limitations in the models. They're still, they're not going to be able to do what a human does at this point. But the amount of progress that we're seeing is just tremendous.
Way beyond what mine
Can you
does.
ask it to move the arm, do something to the robot, move the robot arm?
No, that requires that's only wired up for the OpenAI agent as of right now. It'll be different by next Tuesday probably. But right now, yeah, and that's the one that I broke at 3 a.m. this morning. So I can't do that. I mean, I can force it to move, but that's not the AI moving it. That's just.
Yeah, it should point out that the Robot Builders Night virtual shows that being done.
Yes, yeah.
That's
I
on
did
August
demo
12th.
that previously. Yeah. Okay, so how are we for time? That's gone a lot longer than I thought it would. Without anything to show for it.
Well, I would say that it was been very informative. I really appreciate
Okay,
the work you did.
Yeah, it's a lot of work.
So I could go in and show you how those prompts are constructed, sort of briefly, so that you get an idea that they're actually pretty complex, or I can save that from RBNV or something. People might be a little tired at this point.
Well, no,
When's the pizza
give
coming?
us an example.
Huh?
Pick up a cool example.
All right, so Actually, I'll do it through insert.
And to get into this, what would you suggest? Just ask the chat bot, like, how do I create a really simple example? And I got an Arduino and I want to turn a couple of lights on and off, and give me some help building an API.
So you're actually asking how to get into using LLMs as a programming assistant?
No, I meant.
Or in this specific.
This
Huh?
thing, but with a simple example.
Yeah, you can do it. So like, this isn't the first time a robot's responded to a voice, right? You can do this at the microcontroller level with much more explicit kinds. You're not going to be running an LLM. It's not going to have that kind of.
No, I meant using the LLM, but having it talk to the Arduino or whatever. Am I making
Yes,
sense?
I'm not quite following.
Okay, well, to achieve that goal, I want to have interaction with an LLM, but then I want to have a simple robot and a few simple things.
Yeah, as long as you can build a probably network, but some sort of communication channel where your low-level robot has low-level commands that it can execute. Hopefully, they're not super low-level. They're like behaviors that you can put it modes you can put it into, and if they can be triggered by some little text string, right? Then the LLMs can be configured to recognize a human giving something similar to that command, mapping it explicitly onto that command, sending it onto your little robot, and then the robot, it's up to it to execute on that. And you can, have it monitor and change plans on the fly and things like that. So yeah, it's certainly a possibility. And there's nothing that ties you specifically to RAWs, right? I'm not even sure if I would recommend people who are completely invested in RAWs to take my examples and consider those good examples, right? These are things you can learn from, right? And I have very extensive notes and research and stuff, and I've actually put that into the project, right? And then I have separate Google Docs where I do my initial research, but that includes conversations with AI chatbots and things like that, right? So those are like my personal notes, and then I use the deep research agents to build more formal things from all of the subjects I'm feeling are related or have some sort of impact, right? So and then I store those. And so I've got this specifications. I think I showed this before. So this specifications folder inside by your command, right? It has an analysis section, a research section, and then sessions. And the sessions these are all the logs of my conversations with LLMs while I am developing the system. So you see the warts and all the mistakes that I'm going to say they are making, because the majority of my effort is recovering from the LLM's mistakes. It really is, right? It's managing its context and then walking it back when it pigeonholes itself. There's one thing that I've really noticed, because this is a new topic area, right? These models are new. Nobody else has applied them in this way to like RAWs. RAWs is a newish topic area, changing very quickly. And so I'm running into things where at the edge of its training, at the edge of whatever model I'm using, of its training, it has fragments of knowledge about older APIs that do this stuff. And so the first thing it taps is its trained data set, and it keeps going back to old stuff that's now out of date, just as of 6 months ago or something like that. And I'm constantly telling it, 2025, find an example in 2025. And I have to review every single example that it finds, because it finds the trashiest stuff, and then we backtrack. And if I don't catch it, I can lose a day, 2 days of work, just because we went down a thing and I missed some bad decision, and then I realized later that was there, and then I go back to this log and I find where it did it, and I I looked away for that moment because I don't let them freewheel. I don't, the vibe coding where you just let it go, let it go. That works for trivial cases that are super well documented out in the internet. That's what that works for.
I think that's a key point too, that what you're talking about is new, is open to the public LLMs, right?
Yeah.
So when I work for DoD and contractors, et cetera, they all have their own LLMs and their own books, and it's all proprietary.
Yep.
But this is just what's new on the internet recently, and it's getting better because groups like this that supporting the whole ecosystem.
Yeah.
Because they're learning from you.
Yeah, yeah.
And that seems to be a real sticky spot as far as if I've got it right. I know nothing. I talked to chat bots a little bit. Anyway, but really that ability to know what it knows and to control that, like you're saying.
Yeah.
Where you get burned, but it's
Because it feels
something
very
fragmented.
confident in what it knows.
Yeah,
Right?
yeah.
And and so it wants to go in that direction every time. And it'll make the same mistake 5 times. I had to restart the Gemini agent from scratch 3 different times because it just worked itself into a dead end, and it was more trouble to try to get it to turn around than to start fresh. Right. And this is the very last time I watched every decision it made. It's like I approved every single edit. I didn't let it freewheel anywhere, anytime, and that was the only way I got it started to finally work. Because it made some really bad assumptions, and it kept going back into it. Even stuff where it's doing like I ask it for a deep analysis of what's going on in some section of the API, right? What's possible, what's not. Give it a full list of these are the only references that you need to look at. The answer is in there, and it missed them, and it went back to a way that was deprecated like a year ago.
So did you go and correct it then, and it learned from you?
Yeah. No. So yes, so that's the whole reason I'm keeping all of these sessions, and then and anytime we find a new learning, I tell it. So I also have PRDs. This whole section down here are product requirement documents, and so these are the things that are the actual specification for that subsystem. And I tell it, let's go back and fix it right now, because if you don't fix it right now, and then in the next session I have to tell it, okay, let's start all over again. Look at this PRD, read the whole thing, right? Don't just search through it. Read the whole thing. You gotta like, it's like leading a toddler, through a maze or something like that. Yeah. And yet they do amazing stuff, right? And like syntax errors are a thing of the past.
Well, it's pretty smart. It knows the cone is orange. It's got some image labeled that instead of calling it red or, but then
it may have just assumed it was orange, right?
Yeah,
Because
well,
but if it had called it red and then you said, no, it's actually orange, would it actually learn from that the next time?
it would it would in that session, because I'm doing content reinjection, right? I still have this concept of what a conversation is. So a conversation is bigger than a session, because I've got this aggressive session cycling to keep costs down. But a conversation is where we've had a series of continuous sessions without a huge timeout, right? And right now, because I don't actually have human detection built into it, like it can describe you, but it can't remember who you are. If I tell it you are Doug, it will remember that for that session once, and for the entire conversation, because I'm re-injecting that. But only if I first ask it to describe you, right? Because you might not always be the only man standing, right? But if I ask it to describe you to the extent that goes into the context, and it is attached to the name Doug, it can figure out who you are. But without something like RAG, building a database of context that extends beyond those conversations, it's not going to remember you from one conversation to the next.
But isn't that when entire conversation saved, and then can't you reboot or restart that in your next
I'm not logging that conversation. That's just live in memory for that
So
conversation.
can you log it and then reuse it later?
I could, but it would get unwieldy very quickly. So the context window is another thing that we keep fighting against, right? And the good news there is that GPT-5 just upped the context window to 400,000. Google Gemini 2.5, that's at 1 million tokens. Anthropic is responding to GPT, and they're increasing theirs to 400,000 from 200,000. Those are all good moves, right? It's actually still a very small amount of data. Now, if you think about the number of books, it's impressive, right? But you start putting video frames and audio and stuff like that, it disappears really, really quickly, right? So that's why there's this whole other field, which we're not going to get into now, called RAG, right? Where you store knowledge, specific knowledge domain data, documents typically, that kind of stuff, into a vector database, so that you can do like nearest neighbor search and other things like that to pull it back out dynamically in text form as an optimized version of text injection, right? So this is a whole other area, but that's where I want to go with developing an understanding of what, in my case, my property is like. Yeah,
I was
right.
gonna say, because that's a real world example. This is a security robot. It's going to be on a certain piece of property. You could take images of all that property and label it, have your own database set up. So you know exactly.
Exactly.
You can
It
have
knows exactly.
GPS coordinates and grids and everything.
Absolutely. Yeah. And you can even like track how it changes through the seasons. And
Yeah.
stuff like that, right? So yeah. So that's my next adventure once this is buttoned down.
So sounds like because of where everything is now, you're just going to be using Gemini. So you're going to put your effort on Gemini right now.
I'm gonna fix the problem with the OpenAI one. So far I haven't done anything to, like, beyond this group. I haven't shared that the repository on GitHub. It is open, but you know, I think at some point people who are looking for examples, if I get it to the point where I can take off the "don't touch this is bad" pre-alpha code, if I can pull that out of the README at some point, then I'm doing a little bit of help for the community, sort of like you're pointing out, to sort of share some experiences, and maybe somebody takes, you know, to the next level. So
What percent of your time are you spending on this?
again, I was up all night. Yeah, it's like a death march project for me right now. Hopefully that'll tail off again. But I also already committed to like doing another presentation on it in October at a meetup there. So by then it should be more polished, and I'll have a slightly higher chance of pulling off the actual demo. Yeah.
You haven't doing a lot of coding yourself, or are you doing a lot of?
I'm doing it's AI first, right? So the AI assistant is doing all of the typing that is coding, and I'm catching mistakes. And more often than not, so you saw that I'm using Windsurf, right? So I have an IDE that's actually looking at the project directly on the robot. I'm also using Claude Code on the robot. That's my primary programming interface, and that's just telling it what to do, right? I see the diffs that it suggests. Again, I don't let it freewheel. I just say, I almost always run it in plan mode, and almost always with Claude Opus instead of Opus 4.1. That's their leading thinking model, because Sonnet is it'll lean into those mistakes just like that. But yeah, it's like that. My experience is just telling it to code better, right? Giving it direction, right? So I'm the one who's making the architectural decisions, but I involve it all the way through the process, right? You know, like and I don't do it just with Claude Code there. I also use OpenAI. Like I do most of my initial research in OpenAI's GPT, right? ChatGPT, and usually with deep research or the latest thinking model there.
So all the stuff that you just told us, including ROS, do you have a slide that shows that? It'd be really interesting to see that on a slide.
Shows what?
Shows like kind of like an OSI model, right?
Right.
Like, what do you have on the device? You know, what are you actually doing interfacing? It'd be good to have a slide like that.
Yeah, I should pull. So the node graph. Again, my computer.
Higher level than the node graph.
My computer. Yeah, my computer like crashed last night at 3 a.m. something like that, right? So I was trying to recover so I have on my computer. It's not crash. It's just the Wi-Fi stack disappeared, right? And so I've never run into that before, but I can't get anything off of it right now. But on there is a architectural diagram that it shows a big picture.
Is that in the GitHub?
Huh?
Is that in the GitHub?
It's not in the GitHub yet. Yeah, it will be ultimately.
Okay. But basically, this is a ROS2 robot.
This is a ROS2 robot.
And
So there's no way to unwind what I've done. You don't need to unwind it because you can just look at the agents, the two different agents, and that'll tell you everything you need to know about dealing with their end. And what you can just sort of do is they're both talking to the same bridge node. So there's an interface that they talk to get the stuff from the robot. And you can just imagine that interface is replaced by whatever it is you need to talk to your specific robot, whether it's RAWs or not. And you'll still have pluggable agents if that's a thing you care about. I cared about that, so I had like common libraries or common functions across different kinds of different providers.
I think the other thing that'd be interesting on a slide for your future presentation would be now you show how you built it because you put a lot of effort into it, but then take just 4 things to do: build, buy, lease, re-engineer, right?
Right.
To take a benchmark that's already out there, a commercial robot. There's like 3 companies that already do that.
Yeah.
And actually get a hold of one of those and reverse engineer it and then see what their OSI model or their architectural model looks like compared to yours. That'd be a good comparison of here's the standard benchmark in the industry. Here's what I did. Look how great I was because I fixed a lot of things that the industry didn't do, right?
I would be dubious that would be the case. You know, they have teams of people working that stuff, and I'm doing this solo.
But I mean, good to see a comparison. Like, what's the standard?
Sure,
benchmark?
if they would actually share that.
So a lot of companies will. You just have to. So we'll talk offline.
Okay. All right. Happy to hear what you have in mind.
Can you hear me?
Is lunch still
Can you
happening?
hear me?
It is. I'm gonna go pick it up in about 10 minutes.
Oh, okay.
I'm
All right.
wondering.
So do you want to go into the sanity? I never showed you the node, the prompt construction, and this is a juicy chocolate down here.
Okay.
If we want to.
In 8 minutes,
Or
the SD card runs out, and I have to make a switch.
well, I
Okay,
mean,
so I'm just
we're
saying.
done. We're done
So
anyhow.
what I'm saying
We can
is
stop right now. I'm happy. Like, I'm pretty talked out, so we don't have to keep going. I think.
Well, I would like to see a prompt.
Huh?
One of
You wanna see the prompt?
one of the questions I have is, okay, so you have a conversation, okay, and you stop it. When you restart it, if you're in a different conversation, you have to reprompt it from the beginning.
So you have to reprompt it every time you start a new session.
Yeah.
Right? And that includes the system prompt, which governs its behavior, right? It's the most important set of instructions that tell it what to do. And these are things that you don't normally get access to, but there is a system prompt running behind your ChatGPT window, right? That governs how you deal with it and what it spits back to you.
Because, I mean, you want
And it's
something that-
dynamic because they'll swap in the background, but you'll never see it, but they'll swap out different system prompts based on what it is that you're doing, like the deep research is totally
Because it would
different
seem
from-
to me like, okay, yesterday you ran this thing, you turned off the computer, you turned off the robot, you started up again.
You're gonna get the,
You could
you're gonna
feed
get
it the
the,
same prompt, but,
Yeah.
but.
but the conditions will all have changed.
Everything else is different behind. it.
All of those conversations that we had with that, in that prior, let's call it conversation, right? Which is multiple sessions with usually one person. Those are lost because I'm not saving them from conversation to conversation. That could change. That's a decision that could be made to remember past conversations. But then again, we'll quickly run into that total context window limit. If you pile 15 conversations, it's all gone, right? So you can't do it just through prompt injection.
I guess what I'm saying is the LLM, the APIs, they're over here. You're having to go access them through the bridge. Otherwise you have a ROS bridge. You have to get these guys started, but you don't know if this is the same anymore. So if you use the prompt into this LLM, the LLM has improved itself. You don't know if you're going to get the same type of response, the result.
So my system prompt does not change from one session to the next.
Okay.
Right?
The API should.
The API won't change. The APIs are pretty stable. The system prompt that I construct is specific to this robot and its capabilities.
Yeah.
Right? And its architecture, right? So as long as that doesn't change, those won't change. You'll see them change in my code base if I decide that they need to be updated, optimized. That's not conversation specific. The stuff that is conversation specific is really called user prompts, right? That's
turn left.
Yeah. Everything that I said and that the robot said back to me is user prompt context, right? Conversational context. And right now, and I really don't want to do this because it's kind of creepy, right? I don't want to save that from one conversation to the next. That does change when you want to do things like, we want to identify the owner of the robot so that person is always trusted. And once it has image, facial recognition as a tool, right, then we want to be able to remember that. And that's the kind of thing that would probably go into a RAG database so that it could be judiciously pulled in when needed and not consume a huge amount of context window. Because you can initially get away with remembering things that are specific to your house or your property, whatever the location that the robot is in. You can just save them as text that just gets injected at the beginning of the conversation. And you can just keep building that up. But it's a very explicit way to manage it, and it consumes tokens very, very quickly. Right? It's not going to be optimized where, like, if you're searching through text that has been encoded and stored in a vector database, that it just automatically pulls out the most relevant stuff. That's going to be a much smaller injection. There's a whole other field that we need to talk about right now, but I know some people here know about RAG. The next step up from that is graph RAG, where you're storing semantic knowledge as well in the database, in a different database, right? But they're connected to each other, so that you're getting much better. You're getting much better, more relevant data being injected back into the conversation, so the LLMs can make better choices.
But once you develop your RAG, say this device is on a security property,
Yep.
and you develop your RAGs, you've got your own database. You don't need the LLMs anymore. LLM is just for the development phase.
No,
Why?
no, the LLM is still the thing that does all of the work, right? So the RAG is really just a hot, on-demand, very focused prompt injection tool.
Yeah, but if you already have your conversations and you already have your commands set up, What do you need the LLM for? If you've already, and you already have your own database of your own grids and location on the property.
If you're talking about just getting data out of the RAG database itself, you can do that with very explicit, you can save queries, you can do anything you want there.
Yeah,
right?
you can build your own.
Yeah, absolutely. But in order to have a human-like conversation about it, because again, I'm not talking with some technical professional when some random trespasser comes up. You know, I want it to be able to talk with that guy and say, "What's up, dude?"
But it's still
Right?
gonna give basic commands. Stop, don't move, get on the ground.
Oh, sure,
You know,
sure.
put your hands behind your back.
Yeah, the database of interactions that you would
It
store in the
doesn't
RAG.
need to speak French to your intruder. So what do you really need the LLM for?
Might need to speak.
Okay,
Yeah.
Scott,
Yeah.
hold this conversation.
Well, we're done, right? We're going way over. at this point.
Okay,
Paul was asking if
Wait,
you want to do a
Phil,
poll
it's-
session next month.
all right.
Oh, now he wants to get out of his,
Such a big,
now he wants to get out of his talk.
yeah, Paul,
I
get out
was
your
not
phone, yeah.
prepared because I thought when I said okay to this, I thought I had another week. I thought it was next Saturday.
Oh, no.
Yeah, I'll sneak
I thought we went to the last Saturday of the month.
No, third.
Still a third.
Yeah.
I swear. Whatever. Okay.
We got a door prize to hand out. Can I do that before anybody leaves?
We're gonna have pizza.
Yeah, the pizza's coming.
Yeah, I gotta go fetch it.
Sphere, it's pretty cool. It's
far?
a
right.
programmable,
I might be going.
LED sphere. Anyway, I'm gonna give it away. Can I do that?
Oh, what is it?
Can we do that? We don't have to waste and stuff.
Oh,
Anyway,
yeah.
door prize. So what I'll do is, whose phone number is closest ending in 42? Anybody have a phone number fairly close to that? Yeah. Okay, how about this? How about, how many people in here with a last digit of 5? Any 5 last digit phones? Okay, Dan, okay. We got 3 people. Okay, so okay, out of you 3, okay, now I'm gonna narrow it down. The next to the last digit, how about a 2? Bam, you got it. You got a sphere. Actually, if you open it up, have you ever seen one of these?
A Sphero?
Yeah.
Yeah, it's a LED sphere and it's programmable. You can app or you can just tap it. Actually, if you open it. it's-
All right, stop the recording for now, but.
So you're not
Yeah.
processing the output, you're getting this voice output from the robot. That's the voice, there's the LM giving you. You're not processing